Here's a review for Unit 2 for Math 0320. We're going to be dealing with beginning of functions, function notation, domain, range, and graphing of some functions. Our first question here says, what are the domain and range of the following? Our domain. The domain is all the x values. So it's going to be 9, negative 2, 4, and negative 4. My range are all the y values. So I have 3 and I have 5. Do not write, if they've been repeated, do not write them over and over. In question number 2, this is in function notation. Here it says find f of negative 3. So to find f of negative 3, I'm going to go in and substitute. Everywhere that there is an x variable, I'm going to be going back and plugging in a negative 3. So I'm going to plug in negative 3 here, here, and here. Now it's a matter of just doing some arithmetic. This becomes 3 times negative 27. This becomes minus 2 times 9. This is a minus 12 and a minus 7. This becomes a negative 81, minus 18, minus 12, minus 7. They're all negative, so I can go through and add them together and keep the negative sign. So it's going to be negative 118. For problems 3 and 4 here, we're going to be employing the vertical line test. Well, the vertical line test says, hey, if I can draw a vertical line and it hits in more than one place, it is not a function. With this one here, no matter how I draw my vertical line, it only hits in one place each time. Therefore, yes, this one is a function. For number 5, it says graph f of x is equal to the absolute value of x plus 3. Remember, I look at this right here, this plus 3, so I do the opposite of it, and that's where my vertex has been moved to. So it's going to be moved to negative 3. Absolute value functions always make a V shape. So my equation will look like this. If all else fails, you could always go back and make you an x and y chart, plug points in. Remember, though, that you have to make a V shape. For this one right here, this is a parabola, and our parabola equations always make a nice pretty U shape. This minus 4 on the outside tells me that it's going to move my graph up and down. It's going to move it down 1, 2, 3, 4 places. And it's going to make basically the parent function just translated down 4 units. Again, you could always go through and make an x and y chart, plug points in for x, solve, and get points for y. Just remember that you have to have a U shape as your final answer. For number 7, if you need to, rewrite this equation so it becomes h of x is equal to negative x cubed plus 2. If you remember, our parent function looks like this, going this way and then going back down this way. What this is going to do is it's going to actually move my graph up 2 places. That's what the plus 2 does. So every point gets moved up 2 places. The negative here in front flips everything over. So this one's actually going to look like this. And again, as always, you can go through and plot some x and y points. Don't forget to do a few negative and a few positive. For number 8, we have to complete our table here. So we're going to go through and we're going to do f of negative 4. So that's going to be 4 divided by negative 4, which would be negative 1. Then I do f of negative 1, which will be 4 divided by negative 1, which is negative 4. I do f of 2. Just 4 divided by 2, or 2. And the last one, f of 8, that's going to be 4 divided by 8, which reduces to 1/2. Plug the x values in, and then do your arithmetic to simplify. Now here at number 9, we have to solve using our substitution method. So I'm going to take x minus 2y is equal to negative 3, and I'm going to get the x all by itself first. So I'm going to take and do a plus 2y to both sides. So I now have x is equal to 2y minus 3. I'm going to go back to my other equation here, and instead of putting x in there, I'm going to plug in 2y minus 3. And I still have my minus 4y is equal to 9. I distribute, so that gives me 10y minus 15 minus 4y is equal to 9. Collect my like terms. So collecting my like terms here, I have 6y minus 15 is equal to 9. We add 15 to both sides. So I have 6y is equal to 24. I divide both sides by 6. And I find that y is equal to 4. I have now found 50% of my solution. I have found the y value. I still have to go find the x value, and to do that I go back to my equation here. It's going to be x is equal to 2 times 4 minus 3. Well, 2 times 4 is 8 minus 3, and 8 minus 3 is 5. So my final solution is 5, 4. Now in problem number 10, we can use substitution, we could use elimination, any process that we choose to use. I'm going to go through and first get rid of the fractions so we don't have to look at them. So I'm going to do so by multiplying my top one here by 10, and I'm going to multiply the bottom one here by 9, and that will clear our fractions out of the way. So that our top equation becomes 15x minus 6y is equal to 30. My bottom equation becomes negative x plus 3y is equal to 24. If I multiply my bottom equation by 2, this equation here by 2, I'll be able to eliminate the y's. So my 15x minus 6y is equal to 30 stays the same. This becomes a negative 2x plus 6y is equal to 48. And now add straight down. And when I add straight down, these two here have been eliminated. This gives me 13x is equal to 78. I divide both sides by 13. So I find that x is equal to 6. And again, I've only found 50% of my answer. I need to go back and work on the other part. I'm going to use my bottom equation that I've already cleared the fractions from, so I'm going to use my negative x plus 3y is equal to 24. So it's going to be negative of what we found x to be. So I'm going to plug in here 6. So how do we get rid of a negative 6? We're going to add 6 to both sides. So plus 6 plus 6. 3y is equal to 30. I divide both sides by 3. Y is equal to 10. And there's my solution. In our next problem here, we have to assess to solve by graphing. So my first equation here is already into y equals mx plus b, so I get my slope and my y-intercept. My slope is 1/3, my y-intercept is -2. So I'm going to go plug in here at -2. I'm going to rise 1, run 1, 2, 3. And there's my solution to that one. This next one's already set up for my x and y intercepts, nice and pretty. So if I go do these things here, if I plug 0 in, this is going to give me 3 because 9 divided by 3 is 3. And then if I plug 0 in for the y, that's going to give me -9. So I have -9, 0. And then I have 0, 1, 2, 3. Draw my line through these points. Notice these two equations are these two lines are parallel. Therefore, we would write no solution. Or you could write parallel lines. Our next equation over here in problem number 12 says solve using the addition method. So I'm going to have to multiply both of my equations. I multiply my top equation by 2 and my bottom equation here by 3. In doing so, that gives me 10x plus 6y is equal to 54. On the bottom, I have 21x minus 6y is equal to 39. I now add straight down, and in doing so, the y's have been eliminated. So that gives me 31x is equal to 93. I divide both sides by 31. And I find that x is equal to 3. Well, I've only found 50% of my solution, so I have to go back and find my y. So I'm going to use my top equation. The 5x plus 3y is equal to 27. Go back and plug the 3 in. So that's going to be 5 times 3 plus 3y is equal to 27. So I now have 15 plus 3y equals 27. I'm going to subtract 15 from both sides. So I have 3y is equal to 12. Divide both sides by 3. Y is equal to 4. And there's my final solution. Looking at problem 13. Now here, problem 13, we have 3 equations with 3 variables. I like to go through and label each of these. I'm going to call this one A, B, and C. And in surveying my equations, I notice my y variables all have a coefficient of 1, and then some are negative, some are positive. So looking at that, I'm going to take and put A and B together. And in putting A and B together, I do not have to do anything to either one of them, so I'm just going to rewrite them. 4x minus y plus 2z equals 0. 2x plus y plus z is equal to 3. I now add straight down, and in doing so, my y variable has been eliminated. So I now have 6x plus 3z is equal to 3. And I now have equation D. I'm now going to go back and put together equations D and C, because my y variable is easy to eliminate there. Whichever one I eliminate the first time, I have to eliminate the same variable the second time. And again, I do not have to multiply either one of them by anything. So I have 2x plus y plus z is equal to 3. Here I have 3x minus y plus z is equal to negative 2. I go and add these together, and in doing so, my y variable has been eliminated. I now have 5x plus 2z is equal to 1, and this gives me equation E. I now have to put equations D and E together, D and E. And in doing so, I am going to have to multiply these by something to make one of them be eliminated. I'm going to eliminate my z variable, so I multiply equation D by a negative 2, and my equation E by a positive 3. So I now have a negative 12x minus 6z is equal to a negative 6. Here I have 15x plus 6z is equal to 3. I now add straight down, and in doing so, my z variable this time has been eliminated. I am now left with 3x is equal to negative 3. I divide both sides by negative 3, by positive 3, sorry, which gives me x is equal to negative 1. Now with these, we're not going to get an ordered pair. We're going to get an ordered triple. So I now have my negative 1. So I only have 1/3 of my solution. I now need to go back to one of my other equations. I'm going to use equation E. 5x plus 2z is equal to 1. I'm going to plug in negative 1. So I have 5 times negative 1 plus 2z is equal to 1. So negative 5 plus 2z is equal to 1. I'm going to add 5 to both sides. 2z is equal to 6. I divide both sides by 2. Z is equal to 3. Z is equal to 3. I now need to go back and find my y variable. To do that, I'm going to go back and use equation B. I could use any of the equations, A, B, or C. I'm choosing B because everything is positive, and my coefficient for y is 1. So I go back and substitute 2 times negative 1 plus y plus 3 is equal to 3. With this right here, this gives me negative 3 plus y plus 3 is equal to 3. These two 3's cancel each other out, so I find that y is equal to 3. I now have my entire ordered triple. Looking at problem 14. In problem 14, it's a similar type situation. Here I'm going to go through and eliminate my y variable again. First, I want to start off by labeling them A, B, and C. I'm going to put A and B together. A needs a 3 though, so I'm going to multiply everything in A by 3 so I can eliminate my y variable. So that gives me 3x minus 3y plus 15z is equal to negative 18. Then I have 3x plus 3y minus z, not 6. Let's try again. Z is equal to 10. I add straight down, and in doing so, my y variable has been eliminated now. So I have 6x plus 14z is equal to negative 8 in equation D. I'm going to do the same thing with A and C now. A and C. Again, A needs to be multiplied by 3 in order to make my y variable be eliminated. So I have 3x minus 3y plus 15z is equal to negative 18. The C equation does not need to be eliminated. I mean, it changed. And now add straight down, and in doing so my y variable has been eliminated, and I have 4x plus 17z is equal to negative 13, and that's equation E. And now I need to put D and E together and eliminate the x variable this time, because that'll be our smallest least common multiple that we can find. Oh, wait a minute. Oh, that's right. So I'm going to put D and E together. For D, I need to multiply it by a negative 2. Negative 2. E, I'm going to multiply it by a positive 3. So for D, I get negative 12x minus 28z is equal to a positive 16. For E, I'm going to get a positive 12x plus 51z is equal to a negative 13. It's not negative 13, negative 39 maybe. Remember to multiply it all the way through to all the pieces, negative 39. I now go through and add straight down, and in doing so, my x variable has been eliminated. I now have 21z is equal to, and not 21, 23. Let's try again. 23z is equal to a negative 23. I divide both sides by 23. And I find out that z is equal to negative 1. I have now found 1/3 of my solution. I need to go back to one of my equations, D or E, to find my x variable. So here I'm going to go and use equation E just because the numbers are smaller. So I'm going to do 4x minus, plus 17 times negative 1 is equal to negative 13. So I have now 4x minus 17 is equal to negative 13. I add 17 to both sides. And here I find that 4x is equal to 4. I divide both sides by 4. X is equal to 1. I now need to go back to one of my original equations. So I come back up here and look and see. I have A, B, and C. I'm going to use equation C because everything is positive. So that's x plus 3y. So we're going to use equation C. X plus 3y plus, make sure I write these down correctly, 2z is equal to 5. 2z is equal to 5. So we go back in and substitute now. So I'm going to have here a 1 plus 3y plus 2 times negative 1 is equal to 5. This becomes 1 plus 3y minus 2 is equal to 5. 3y minus 1 is equal to 5. We're going to move the 1 to the other side. Plus 1. Three y is equal to 6. We divide both sides by 3. Y is equal to 2. So my ordered triple is going to be 1, 2, and then negative 1. Remember, you have to make sure you're organized and pay attention to what you're doing as you are working our systems of equations with 3 variables. Here in our next one, here we have some word problems. A plane flew 1,200 miles with a tailwind in 2.5 hours. The return trip against the wind took 3 hours. Find the speed of the wind and the speed of the plane. Well, we have to remember that our distance is equal to the rate times the time. It's a good idea to make a quick little chart. I have D, R, and T. Here I'm going to do the with the wind. Here I'm going to do against the wind. My distance is the same for both of these. That does not change. My time, they give me my time. Tailwind, that's with the wind. That's 2.5 hours. And against the wind, that's 3 hours. What I have to pay attention here is for my rate. With the wind, that's my plane plus the wind. Against the wind will be the plane minus the wind. So my first equation is 1,200 is equal to 2.5 times P plus W. Well, I can get rid of the 2.5 on the outside by dividing both sides by 2.5. So I'm left with here P plus W is equal to 480. My second equation is going to be 1,200 is equal to 3 times P minus W. So here I can divide both sides by 3. So I have 400 is equal to P minus W. Now I can stack these together. 400 is equal to P minus W. And I can add straight down. And in doing so, my W's will be eliminated. I am left with 880 is equal to 2P. Divide both sides by 2. The plane speed is 440 miles per hour. To find the speed of the wind, I can use my equation. 480 is equal to P plus W. So I do 480 is equal to 440 plus W. I subtract 440 from both sides. My wind is blowing at 40 miles per hour. Problem 16. A total of 330 tickets were sold for an opening performance of The Frog and the Toad. Children's admission was $8. Adult tickets were $13. The ticket receipts for the performance was this amount here. So here's our information we need. So I know that if I add the adults plus the children, I have to have 330 tickets. I know that if I multiply the adults by 13 tells me how much money I raised for the adults, plus 8 for the children tells me how much I had for the children, and together I had $3,215. Well, I can take and multiply this top equation by negative 8, which then gives me negative 8a minus 8c is equal to a negative 2640. I now add straight down, and adding in straight down, I find out that these two have been eliminated. So I now have 5a is equal to 575. I divide both sides by 5, and I see that A, my adult tickets, is 115. So I now say 115 plus C is equal to 330. You subtract 115 from both sides. And we see that we sold 215 children's tickets. Make sure you pay attention to what you're doing. Take your time, but again, as always, do not take too much time. And good luck.